So let's look at our warm-up, reviewing a couple of things. The first one, in number 1, we're simplifying, and that does mean that you can't have the same base and none of your exponents can be negative. So a couple of things here, and you can do these in different orders, either way is fine, is I'm going to look at my y since that's where my negative exponent is. And I'm going to take this y to the negative 3 and I'm going to move it to the bottom and put a y cubed there. That's the only negative exponent, so that's the only one I need to do that with. Now the 9 and the 12 are bases. Those are not exponents, so we're going to divide them since it's a fraction, and we can divide them both by 3. So that's going to give me 3 and 4 to start with. Then I'm going to look at my x's. There are more x's on top than there are bottom. There is 1 on the bottom and 2 on the top, which means we're going to have 1 left over on top. My y's are now both in the bottom, which means we're going to add their exponents because they're being multiplied together. So y squared times y cubed gives me y to the 5th. So looking here to make sure it's simplified, 1, the bases are simplified just like any fraction. None of my bases repeat, there's not more than one of the same, and there's no negative exponents, so this is my simplified answer. 3x over 4y to the 5th. So then the next one says to use whole, integer, rational, and irrational to name all the subsets of the real numbers. So in number 2, I have negative 2.5. Well, the first thing to ask, is that rational or is that irrational? Negative 2.5 is a decimal that ends, means I could write it as a fraction. So this is rational. Once I answer the question that it's rational, I then need to ask the following question, is it an integer? An integer can be negative, but it can't be a decimal, so this means rational is the only answer for number 2. Number 3, I can simplify that. Square root of 25 is 5. Square root of root 1 is just 1, so that's 5 over 1, which is just 5. So again, our first question, is it rational or irrational? Well, it's a number that stops. It isn't even a decimal, so it is rational. Once I decide it's rational, I then have to decide, is it an integer? Well, 5 is not a decimal or a fraction. It is positive, which integers can be. So yes, it's an integer. Then I have to ask if it's a whole number. Well, whole numbers are any positive number that isn't a decimal or a fraction. That's 5, so yes, this is also a whole. So to be correct, you would have to answer all 3 of these categories. If you leave one off, you haven't named all the subsets. Here's the ready to go on page from yesterday. Number 1, sorry for the mess there. That's a square root of 36 minus the 4th root of 81, which turned into 6 minus 3, which is 3 for number 1. Number 2, you can see the work. Make sure you see the arrow. Same thing with number 3. If you change that to a decimal, that is okay, but I would prefer you stick with the fraction for that. And number 4 is 13. 5 and 6 are your properties. Power of a product says that you can multiply them. And number 6 is product of powers, since the bases are the same. Number 7 is 32. That's using that equation. 8 through 11 is just like our warm-up, and again, you have to label them all to be correct. You can't just leave one off. Pause if you need to check any of your answers before I scroll this up. Irrational numbers under addition are closed. 13 rational numbers under multiplication are closed as well. And 14, in real numbers, you have whole, integer, and rational, and irrational, which irrational is that set all by itself. If you call it irrational, you can't call it anything else. Good luck on your quiz today, and enjoy your break. Since Friday, we'll just be kind of reviewing what we've done so far.